Notice that this next problem, if you look at problem number C, is not factored. So you cannot cancel anything at all because nothing is identical and we have not factored yet. So in order to reduce, it means we must factor first. So if we look at the top, we can factor out a common factor of 5 as a greatest common factor, which would leave us with x minus 4 on top. And on the bottom, we can factor out a greatest common factor of 3, which leaves us with also an x minus 4 on the bottom. Now we can see that we have a common factor of x minus 4 on both the top and the bottom. This, because they are identical, can be canceled out, which leaves us with our final answer of 5/3. Notice that this means you have to be really good and capable with your factoring. Look at problem D. Again, it's not factored. There's nothing identical. So at this point, nothing can cancel. So we need to begin by factoring. On top, we have a greatest common factor of 3, which if factored out will leave us with an x minus 5. On the denominator, notice that we have a difference of 2 squares. Remember, a difference of 2 squares factors out as the 2 squares, which is x and 5, with one as a plus sign and one as a minus sign. Now notice this does leave us with a common identical factor on both the numerator and the denominator of x minus 5. So we can go ahead and cancel that out. This leaves us with only a 3 on the top and an x plus 5 on the bottom. Notice, because the factor of x plus 5 on the bottom is by itself, we no longer need to write the parentheses around it. So that's our final answer, 3/x plus 5. On problem E, again, we need to factor. So looking at the top, we can quickly notice that again we have a difference of 2 squares, which is going to factor out as t minus 5 and a t plus 5. Remember, order does not matter here as to which comes first and which comes second. On the denominator, we can factor out a factor of 4, which will leave us with t minus 5. Just like the last problem, notice we have an identical factor of t minus 5 on both the top and the bottom. So this can be canceled out, leaving us with a t plus 5 on top and just a number 4 on the bottom. This cannot be broken down any further and must just be left as is. Notice the next problem does have a difference of squares on top, but the denominator does not match up with the numerator, as in the variables are not in the same order. So we need to correct this. So I'm going to go ahead and leave the numerator alone as m squared minus n squared. We will deal with the difference of squares in just a moment. And let's rewrite the denominator in the reverse order so that m's come first like it does in the numerator. We'll notice that the m is a negative m. So when we rewrite it, we need to rewrite it as a negative m. And the n next to it is a positive n, so I need to write that as a positive n when I rewrite it as well. Now we can factor out the difference of 2 squares on top. So we've got an m and an n that are squared. So a difference of 2 squares means that we will have a m minus n and an m plus n. And on the denominator, you would think that we can't factor out anything, but as a reminder, when that first term is negative, we can actually factor out a negative or a -1. So let's factor out a negative or a -1, which will change the signs of both the m and the n. So the m was negative. By factoring out the -1, it becomes a positive m. And then the positive n now switches to actually becoming a negative n, which, not coincidentally, notice we now have a common factor between the top and bottom of m minus n. Notice that right here. The m minus n is now identical in the top and the bottom, so they can be canceled out. We're not done yet, though. We get m plus n on top, and we still have a negative 1 on the bottom. Now we have to simplify this if we can. Remember, dividing by a negative 1 flips the signs of everything. So we have everything as positive on top, so dividing by a negative 1 will make everything negative now on top. This is our final answer.